Bienvenidos, Ushamdi, and welcome to this Hut8 networking Techtorial. In fact, this is going to be the final module, module number 11, in our introductory ASA basic configuration and deployment series. So again, this is the final module, and let's go ahead and dive in. You can see the title is errata, and so we're going to go back over two topics that we've discussed at length, and that is port forwarding as well as split tunneling. And these are probably two of the features that you're going to be looking to implement if you have your ASA firewall installed at your house, maybe home office. And so again, odds and ends, split tunneling. Now you'll remember that when we VPN'd into our network originally, that we did not have connectivity outbound to the internet. We could access things on the local network, but we were unable to connect to things outside the network. And again, without enabling split tunneling, that is the behavior that we're going to see. Now, there are other ways to achieve this same goal. And so one of them is called hairpinning or U-turn. Sometimes you'll hear it referred to as U-turning the traffic, where you allow it to come in that outside interface and then go right back out the outside interface. And so that's a possibility as well. But we'll cover split tunneling because it's very straightforward and very easy to set up. There's only one thing that we really need to focus in on, which causes a lot of learners some confusion, and we'll talk about that, and that's going to be the traffic to be tunneled and what that means and what network we're going to choose. So again, if you can't access the internet via that outside interface on which the VPN connection is established, and let's go ahead and see what that looks like. So here we are, and again, you can see this is the iPad here, and up here at the top, you can see it's kind of syncing up. It's connected via a USB cable, and we're recording here. So if I was to pull the AnyConnect client up, and for just a split second, I'm going to lower this down here while I type in my password. And again, I'm hotspotted through my cell phone. So let me get my password in here. And while I'm entering this in, the first thing that we're going to do is we're going to go ahead and check on that. Oops, sorry. Let's bring that back up here. There we go. And let's check on, you can see that we're connected in. We've got that little VPN indicator there on the top left right here, right below the mouse. And so if I was to iconify that and bring the ping utility up, you can see I'm pinging something inside the network, 192.168.1.69, which is just happens to be the same iMac. But let me stop that. And what happens if I try to ping 8.8.8.8? So I'm going to try to ping out to the internet and take a look at what's happening. So again, you can clearly see here that I'm unable to connect to the internet. And it may be the use case, again, and if this is, small office, home office, or something that you're doing at your house, when you connect in, it's possible that you'd want to access the internet while connected in. And so the entire concept of split tunnel, it's all about the traffic that's being tunneled. And I apologize, let me get the drawing tool up here. So, and what do we mean by tunneled? Well, if this is my ASA firewall, and that is my outside interface, right? And that connects to the big bad internet out here, right? So we'll just say iNet. And I'm somewhere out here on the internet, and I'm VPNing in. Well, once that VPN connection is established, right, I have a tunnel. And so by default, and I'll put some slashes in here, by default, all of my traffic, all of the traffic from the client is going to be tunneled through the internet to the ASA, right? And once I'm tunneled through, I'm allowed to connect to those local resources. And in fact, if we were to look at the ASA, this is my ASA. This is no longer a 5505, by the way. It's a 5510. But again, the behavior is going to be the same. If you were to say show route, you would see that there's a route for the locally connect or for the remotely connected client here. This AnyConnect secure mobility client PC out here, or Mac, whatever the case may be. You'll see that there's local routing information created for that on the ASA. And so all of that traffic is in the tunnel. Now, when you split the tunnel, or when you do split tunneling, what you're telling the secure, or I should say the AnyConnect secure mobility client, is you're going to identify a network for whom you wish to tunnel the traffic, right? Or for which traffic you still want to come through this protected tunnel to the ASA. And the ASA and the client, right, that secure mobility AnyConnect client up here, the ASA and that AnyConnect client are communicating with each other, and the ASA will signal the client and tell it, hey, this is the network for which you are still going to tunnel the traffic. And if it's not in this network that has been identified, or it could be networks, right? It could be your inside zone, if you've got a prod zone, whatever the case may be. If it's not identified as the network for which you are tunneling, then you are going to split the tunnel, and all other traffic not destined to whatever the network may be. So again, for example, if I want to do split tunneling, but I only want the tunneled traffic to be for the inside 192.168.1.0/24, then I would identify this network as the network to be tunneled, which means it's going to travel inside that SSL VPN into the ASA, and then the ASA will deal with it. In other words, everything else, all other networks other than this 192.168.1.0, which is my inside, that is going to split out and go to the internet, out the unsecure portion of the tunnel, if you will, right? So it really never goes into the tunnel. It's just going to go out the internet connection to the internet. And so that is what split tunneling is all about. Now, this is typically what causes the confusion, is when we go, you'll see it'll say you'll have to identify the network to be tunneled. Now, it's not the address range or the block of addresses that you're assigning to these remote access VPN clients, right? It is not that address block. And I apologize, iTunes can't connect, so that's okay. What it is it's the address block of the network behind the ASA that you want to give this remote client access to and keep that traffic inside the encrypted tunnel. Again, all other traffic we're going to leave outside the tunnel. So as you can see here, the 8.8.8.8, right? Can I ping it? No, I still can't ping. So let's stop, and we're going to disconnect here, because we've shown that by default, with the default settings here, that we can't connect. So let's disconnect, and let's go ahead now and set up split tunneling. So on my box here, if we go to, you would go to Configuration, Remote Access VPN, Network Client Access, and we're going to be looking for the group policy, right? Because this is going to be where we created, and again, if you've watched the previous two modules where we talked about the AnyConnect client or the SSL clientless VPN, in both of those scenarios, we identified a range of addresses that we would assign. And so on my box here, on the demo that we ran, I was using the inside range, and you can certainly do that. However, I typically like to do a different range. That way you can tell right away if you were to do a show route, you would be able to see that that range of addresses, which should be, something that stands out, like maybe 10.254 or 10.255, 254.0, something that it's like, yeah, that is clearly not one of the typical inside addresses in my network. So you would go to the group policy. So remember, here's the clientless one that we created during this series. Here is the client, the AnyConnect client Hut8 remote VPN policy group or group policy. And remember, it's the group policy where we dictate what's going to happen when these clients come in. You can see right here, SSL client, and then over here, SSL clientless. So let's dive into this Hut8 remote VPN, and we can see here the name of the group policy, right? And we're good with these settings here. We'll leave those the way they are. We want to come to advanced, and that is where you see split tunneling. Now, there's a couple things we're going to change. And again, this is my my personal firewall, so you'll see that it actually has some things like right there. So that's already going to be set up, but we'll talk through how to set that up. So the first thing we change is the policy. You'll notice when I had the inherit selected, it doesn't show anything here, because what is the split tunneling policy going to be? Am I going to tunnel all networks? Well, tunneling all networks, what do you think that is? Yeah, that's the default. So by default, when we are using that AnyConnect client or we're using the SSL clientless VPN, we are tunneling everything. And again, that's kind of the challenge that we have right now is that, hey, I'm on the road. I want to VPN into my house. I want to, check on some of my local servers, whatever the case may be. But at the same time, I want to have internet access. So tunneling all networks, that's what we have right now, which means everything is coming through that encrypted tunnel to the ASA. Then we've got tunnel network list below, and then we have exclude network list below. Well, we're going to pick tunnel network list below. And then, of course, we would want to uncheck. We don't want to leave it as inherit because then it's nothing here, right? We want to specify for which networks do we wish to tunnel or continue to keep that traffic encrypted all the way through to the ASA firewall. So again, this is showing up here because I've already configured it. Yours would be blank, and then you would come over to manage. Now, you can see that we've got a network listed here. Yours would be blank, and you would click on add, and you would create an ACL, and that Hut8, and what was the name of it back there? I'm trying to remember. Yeah, the Hut8 prod ST for split tunnel, right? That is the name of the ACL. And then I added an access control entry. So the first one I added was for the inside network. Again, remember, this network that you're identifying here, this is the destination network for which you want to keep the traffic in the tunnel encrypted. And this makes obvious sense, right? I mean, you're accessing your inside network and you can't do that, natively on the internet. You want it in that tunnel into the ASA. So for example, if I had a DMZ as well, I would click on add ACE, we'll say permit, and let's just do, we'll say that it's what? 10.10.10.0/24. And my DMZ network, right? So if it's destined to the 10.10.10.0/24, or it's destined to the inside network through the VPN tunnel, that traffic will remain in the tunnel. All other traffic is going to split out of the encrypted tunnel, right? It actually never goes into the encrypted tunnel, but it's, again, the tunnel is going to be split. It's going to go out the half of the tunnel that's going to be that internet connection. Or, if you're at a hotel, the wireless network at the hotel that you're connected to, that is the network out which that traffic will go unprotected, right? This traffic, anything destined to the inside, or our DMZ, this will stay in the tunnel and be protected. And again, remember, this is not the network or the range of addresses that you're assigning to these hosts on the outside. And I use 192.168.2.0/24, right? So again, it's mutually exclusive, different than any of the networks I have behind the firewall. All right, so we would click OK. So now I've got my policy set up. I'm going to tunnel the network list below, which is identified. And also remember, let me briefly come back here. Remember that this is where we talked again at the beginning of the series with regard to extended ACLs versus standard ACLs. Remember I told you that when you apply ACLs to interfaces on the firewall, the inside interface or the outside interface or whatever the case may be, that you cannot use standard ACLs. And that the use case for the standard ACL, and the most prominent use case, is when you're doing something like VPN split tunneling. Because here, that is a simple standard ACL. That's it, right? And let me go ahead and I'll put a comment in here, inside network, so we can see what this looks like, right? So we've got our descriptions, we've got our permits, right? And then we've got the networks identified right here. And again, the name of our ACL is Hut8 Prod Split Tunnel, or ST. And then the ACEs, or the access control entries inside of that standard ACL, are right there. So let's click OK. And again, that is split tunneling. That's the setup for split tunneling. So now let's click OK. Let's click Apply. We've turned split tunneling on for that remote access group. So instead of pulling the iPad up and then pulling it back down, I'm going to just go ahead and get my password logged in here. And all right, so it's time to pull that back up. So here we are. I'm connected. Now remember, previously with simply the default VPN connection allowing me to connect in, I was able to contact inside resources, but could not connect to anything outside on the internet. And so you can see I've got Clash of Clans here. So let's spice things up a bit. I know that the ping can sometimes be a little bit boring, but what is the difference? Exactly. Did we identify the 8.8.8.8 as a tunneled network? Or are we just basically saying if it's not the 192.168.1.0 or the 10.10.10.0, that it goes out to the internet? And take a look at, oops, sorry about that. And take a look at that. As a result, we have connectivity out the unsecure side of, and I'll say unsecure side of the tunnel. Again, remember, it's not going into the encrypted tunnel. It's simply going out the interface that is connected to the internet, right? Not that VPN interface, because the ASA is signaling that AnyConnect Secure Mobility client, telling it, hey, there's only two networks for which you're going to be sending traffic through the tunnel. And let's confirm, does that work? So can I pull up Clash of Clans? Right? This is clearly on the, and this, again, this is to prove, I mean, this is on the internet. No question this is on the internet and not hosted on something locally here in my basement. And we'll give it a second because, again, it is going and running through my phone. And you can see we are making some progress there ever so slowly. And boy, not the best of connections through the hot-spotted phone. So I was hoping that it would be a little quicker than this. And at this point, they're probably going to be asking me for royalties. This has been up so long. We'll give it a few more. Okay, here we go. All right, beautiful. Right, so there we go. Enemy raid, your village was attacked. So hey, again, proving we've got connectivity out to the internet. But now, what about the question of, well, I think that's great, but do you have connectivity to the inside resources still, right? And that's an important question. So let's see from the ping perspective, is the traffic going to be tunneled in the encrypted tunnel to 192.168.1.202, I believe is a good IP. And it is, right? This is one of the wireless access points I have here at my house. So take a look at that. And that traffic right there is going through the tunnel. So let's check things out here. Let's go to monitoring and look at what we've got here, right? There's the username. There is the group policy, right, that we created in the previous two modules when we did the clientless SSL VPN as well as the AnyConnect client SSL VPN setup. There is the network from which I'm connecting, right? That's out Verizon, so that's clearly not inside my house. And then here is the address that I was given when I came in, 192.168.2.2. Again, I just simply specified a /24 for the 192.168.2.0 as the range of addresses for clients VPN connecting into the network. And you can see here we've got some transmitted bytes and some received bytes. Let me refresh. Let's see if these move at all, right? So keep your eye peeled right here on this column. This bytes transmitted, bytes received. Yeah, and it should continue to go up, right? Because I'm running pings through the tunnel. And you can see the inactivity is always 0 because I'm pinging literally every second, right? So we're connected through, we've got access, but the ping test is good. Let's check out one other, whoops, didn't want that to start again. Let's check out one other test. So let's pull up the VNC client, right? And let's go to this Zavio here and let's see, there you go. And I just remote desktoped into a Windows box that I have here that I happen to be looking at the same PDF here. I've had this up for a while. So again, basically showing that the traffic that is destined to the identified networks, right? Tunnel networks below, network list below. And remember, it's not the address range that you've identified, especially if it's a different address range. It's not that address range. It's identifying the networks behind the firewall for which you want that ASA firewall to signal the AnyConnect Secure Mobility Client to tell it, or your clientless SSL VPN, to tell it these are the networks that you keep in the tunnel. These are the destination networks to keep encrypted in that tunnel. All right, so that is really split tunneling in a nutshell right there. So hopefully that makes sense. Again, we've proved that it works. And let me go ahead and kill this AnyConnect client right there. All right, so now the iPad is back onto the normal network. And let's transition back here and stay on topic. So port forwarding, right? And this was the other one, because these are really the two use cases that come up, especially if you're doing this in, like, your house or small office, home office, small business, is, hey, it's great that we VPN in, but I need to be able to get to the internet when I'm VPN'd in, or port forwarding, right? So maybe you've got a box behind a web server. Again, the VNC server is another good example of that as well. And so there's a couple of ways that we can handle this. So we can set up port forwarding, and another option is to simply create an access list, and here I just call it outside in, right? Meaning the outside interface, and for inbound traffic, which would be traffic coming in from the internet, right? And I have an ACL here, extended permit TCP, because the VNC server is expecting it's using TCP. And who am I permitting it from? Well, I'm permitting it from anyone. And then the object, if this is your VNC server, right? The object's name is host-192.168.1.33-Zavio, and then equal to the port 8899. Right? So this is an option. And again, that is not technically port forwarding, right? This is simply opening or punching a hole in the firewall to allow that connectivity through. Now, here's the disadvantage of this, is that if someone's using Nmap, they're going to see that you have that port open, and then they can go after that port, right? Because remember, you're setting this port forwarding up, and I'm using VNC server as an example, and the same thing stands true if it was HTTP, right? Port 80. So if I was to open this server up to port 80, then I'm exposing, that server, and we wouldn't keep it, we would probably have it somewhere in like a DMZ, where if it got compromised, it wouldn't be, that big of a deal. But again, you're opening it up so that they can attack that port. They can go after that port. And if they know you're running VNC and maybe there's an exploit out there, they can try to do that. Because that port through the firewall, I'm allowing that in from the internet on the outside interface. In other words, the port is going to respond, right? That port is going to be live. And so then there's a possibility it could be exploited. So in the case of remote desktop, the preferable way to do it would be what? Right? If you're doing an RDP session or VNC, right? Think about that for a second. Think about what we just talked about with split tunneling. What would be a better way to allow that access? Exactly. For a remote desktop scenario where you're allowing connectivity through to your inside network, again, assuming that that host is on the inside network, right? Wouldn't it be better to basically VPN in, right? So you would VPN in just like I just did, and then you would use your VNC viewer using the local 192.168.1 address of the VNC server. And remember, all of that traffic, all of it is in the tunnel. Now, VNC encrypts the traffic as well, but remember, you're leaving this port open. If you follow this approach, you're leaving the port open. So you may be exposing yourself to, so the VNC traffic might be fine, right? But you've left a port out there that maybe someone can launch an exploit against. So again, you can punch a hole in the firewall just like I did here, allowing the traffic inbound from anybody, excuse me, anybody on the internet to that VNC server. Or my recommendation would be VPN in, right? Because it takes, you saw how quickly that works. So if I was to pull back my, where did it go? Is it down over here? So if I was to pull, did we icon it? Yeah, we did. So if I was to pull this back and pull the AnyConnect up, you can see how quickly the AnyConnect connects, right? Boom, right away, untrusted server. Type in my password and we're in. So I'm going to go ahead and click cancel there. So type my password in and we're in, and then you can conduct the remote desktop session. Again, remember, the alternative to that is to punch a hole. And with port forwarding, it's going to be much the same or very similar. So let me build this out again. Think about security, and you may want to use your remote access VPN capability. So if we were to come back here, I'm going to go to, so here's how we do the port forwarding setup. So I would go to configuration, we're going to go to firewall, because what we're going to do is we're going to go ahead and we're going to create a NAT rule. And so you can see up here, we've got this add button, right? And so this is where we're going to click on add, and we can simply say, and actually, I apologize. Let me get into NAT rules. And you can click on add, and you can say add NAT rule before network object, add network object NAT rule. And so all we're going to do is click network object, right? And so then we get this box here. And so this is where I'm going to put in the inside, right? The RFC 1918, the private address information for whatever I'm interested in that. So I'm going to use the DMZ as an example here. So if I was to say that, object underscore 10.10. And we'll just say that's the web server address, right? So we'll play with the web server here, and I'll say www. So what is it? It's a host, it's an IPv4, and what is the inside address? Well, we said it was 10 dot, oops, 10, can't see in there, 10.10.10.10, and description, my web server. Now, this is where we come down and we'll go ahead and we'll do it as if it was static, right? So I would leave this checked, add automatic address translation rules. The type, I'm going to leave it as static, and the translated address. Now, what address do I want to set up here? It would be the address of the outside interface, or maybe I have a range of addresses. So we'll pretend as if we've got a range, 209.165.200. And we'll say 10. So on the internet, right, and maybe out in DNS, if I'm using GoDaddy, that this is the address that I've tied to the URL or the domain, right, the domain that I'm using. All right, so from here, we've got that in there. Let's go ahead and click OK. And so you can see source interface, any, and actually I wanted, where did I miss out on that? Give me a second here. Ah, there we go, I apologize. So source interface is going to be the outside interface. The destination interface is going to be the DMZ interface. And then, I apologize, I forgot the real map. So let's say that the real port is when connections come in on 8080, we want them to go to 8888, right? So we're going to do that, and then we'll click OK. All right, so from the outside to the DMZ, and then you can see we've got the rule in the reverse direction. And so that is going to allow me to basically forward the port as it comes in on 80 to 8888. And that's really all that's required. And so again, I would click, what I would do is I would click, what am I trying to say? I would click apply here. I'm not going to click apply because I'm going to delete this, but that is port forwarding. And so again, you're going to create that rule. If I were to click apply, then you could take a look at your running config and you would see what that looks like. And if I were to pull this back up actually, and we go back to advanced, again, and this is all that we're doing here is we're saying the real port is 80, the mapped port is going to be 8888. So when I have connections coming from the outside, from the internet into the firewall, right, destined to 209 on the outside on the internet, they're looking for 209.165.210. We know that that's in the DMZ as 10.10.10.10, right? And so the connection is going to show up. It's going to say, hey, I'm here for 209.165.210 on port 80. And this NAT is basically going to say, oh, right. So I'm going to map that to the 8888, and it's going to my DMZ server, 10.10.10.10. All right. So that, again, basic port forwarding, and I'm going to take this out of here. And so that is it, right? That is all that is required in order to set that up. So you've got a number of approaches that you can use. You can do the port forwarding. You can punch a hole. If it's the same port, right, you can just punch a hole and let it come through. You could VPN in the case of like a remote desktop scenario, which is, that's not applicable for a web server. But that is all you would need to do. And so this is going to wrap up the final module of the ASA basic configuration and deployment. And I really hope you've enjoyed this. I hope it's been worth your time. I know some of the videos run for a while and that they're long, but I want to try to make sure that, we cover everything that's sort of in that introductory range and common things that come up typically right away where, if you've got a Linksys or a Netgear or whatever the case may be, sometimes it's a lot easier to do port forwarding than with an ASA firewall, obviously. But again, we've covered a lot of ground. So you should, at this point, going through all the videos, be able to take an ASA 5505 right off the internet, wipe that guy down, totally clean, get your images on there, do your basic configuration, secure it with AAA, set it up for management access, get your DHCP for your inside network ready to rock. you're going to be able to do port address translation. You can do create remote access VPN for client and clientless. You can do port forwarding. You can do split tunneling. So a whole lot of new tools in your ASA firewall skill set toolbox. Again, I really appreciate you watching. Thank you so much for your time. And that is going to do it. So on behalf of Hut8 Consulting, thank you so much for watching this Techtorial. Have a great night and best of luck to you out there on the wire.